In this video we discuss plus 1 mathematics, arithmetic progressions continued. Exercise 9.2, question number 12. The ratio of the sums of m and n terms of an AP is in the ratio m square is to n square. Show that the ratio of the mth and nth terms is 2m minus 1 is to 2n minus 1. In the question, it is given the ratio of the sum of the first m times to the sum of the first n times is m square is to n square, and we are asked to show that the ratio of the mth term and nth term is 2m minus 1 is to 2n minus 1. Let us solve it. Given as m is to s n is equal to m square is to n square. That is to say, as m by as n is equal to m square by n square. That is to say, sum means m by 2 into, the first term is a, sum to m times is m by 2 to 2a plus m minus 1 d, where d is the common factor of that AP, divided by, as n means n by 2 into 2a plus m minus 1 d equal to m square by n square. Dividing both sides by m by n, we get 2 into 1 by 2 into 2a plus m minus 1 d divided by 1 by 2 into 2a plus n minus 1 d is equal to m by n. That is to say, we can write it as 2a plus m minus 1 d by 2a plus n minus 1 d is equal to m by n. Now cross multiplying 2am plus md into n minus 1 is equal to 2an plus nd into m minus 1. md into n minus 1 minus nd into m minus 1 is equal to 2a into n minus m. That is d into m into n minus 1 minus n into m minus 1 is equal to 2a into n minus m. Now that is equal to d into mn minus m minus nm plus n is equal to 2a into n minus m. That is to say, d into n minus m is equal to 2a into n minus m. Now b is equal to 2a. d is equal to 2a. Now you have to get the mth term and nth term. T m by T n is equal to a plus m minus 1 into d is equal to 2a divided by Tn means a plus n minus 1 into 2a, that is equal to a minus 2a minus a 2 am minus a divided by 2 an minus a. That is to say, we can divide the numerator and denominator by a. 2m minus 1 by 2n minus 1. We got the result. Once again, the question, it is given that the sum of the first term, the first m times, and the sum of the first n times are in the ratio m square is to n square, and we are asked to show that the mth term and nth term are in the ratio 2m minus 1 is to 2n minus 1. This is 2m minus 1, this is 2n minus 1. Now, sum of the first m times is given by Sm, and sum of the first n times is given by Sn. It is given that the ratio is m square is to n square. We can write it as Sm by Sn is equal to m square by n square. Now Sm is equal to m by 2 into 2a plus m minus 1d, where a is the first term and d the common difference. And Sn, that is n by 2 into 2a plus n minus 1d. There also first term is a and the common difference d. Now simplifying, we can divide both sides by m by n. That is half into 2a plus n minus 1d by half into 2a plus n minus 1d is equal to m by n. We can score half from the numerator and denominator. So the fraction becomes 2a plus n minus 1d by 2a plus n minus 1d is equal to m by n. Now cross multiplying 2am plus md into n minus 1 is equal to 2an plus nd into m minus 1. Now shifting nd into m minus 1 to the left and 2am to the right, we can write it as md into n minus 1 minus nd into m minus 1. Now when this 2am is taken to the right, 2a is common, 2a into n minus m. Yes. Now simplifying, d is common, d into m into n minus 1 minus n into m minus 1 is equal to 2a into n minus 1 m. Here d into m into n mn, m into minus 1 minus m, minus m into m, that is minus nm, minus n into minus 1, that is plus n. Now mn minus mn 0, then on the left it is d into n minus m, d into n minus m. On the right it is 2a into n minus m. We can divide both sides by n minus m. Then d becomes 2a. d is equal to 2a. Then we have to get the ratio Tm is to Tn. Tm is a plus m minus 1, d is equal to 2a. Here d equals 2a. Then Tn is equal to a plus n minus 1 into d, that is 2a. Expanding, (2am minus 2a plus a), that is 2am minus a. Here it is 2an minus 2a plus a, that is minus a. We can divide the numerator and denominator by a. Then it is 2m minus 1 by 2n minus 1. Therefore, the ratio Tm divided by Tn is obtained as 2m minus 1 by 2n minus 1. Alright.